on bit strings, and a bunch of other stuff goes on here, and we get the answer down here, and here are the output pieces. All right, so now I want to actually generate some code from this. I won't go into the details of what's happening in those definitions, but I'm using a calc function that translates this into a data type of the syntax of the BlueSpec language, which is the inspiration for Kami, but they're not quite the same. And then I'm going to use an extraction directive to produce a file called target.ml. Let's see what that turned out to be. It's just a whole bunch of OCaml code. And oh, here's our definition at the bottom. And then we call a function that translates it into another syntax tree type. So what I'm going to do is jump in there, make this build a binary that when I run it is going to print a string of BlueSpec code. And let's do that. What did it output? Created something called main.native. And let's write this to target.bsv. Here's the BlueSpec code. It looks pretty similar at an abstract syntax level. Just another way of writing what we had before. There's a little bogus top level module at the bottom there. So there are now commercial CAD tools that will take this and convert it to run on silicon or on FPGAs. I'm just going to use the BlueSpec simulator here. And I have it installed on a remote machine, which is simple. It simplifies the licensing story because it is commercial CAD tools. I'll put this in this directory. And then let's go in there, go to, and I'll just use Emacs to open this BlueSpec file. Here we are. So let's try to compile this. And then it turns out that, oh, I have to run first, set up my environment variables, oops. And for whatever reason, the extraction setup is currently mentioning some unused stuff here. I'll just get rid of that. And we have this thing created. So now I can simulate my top level module. It does nothing. Hope you're all ready for it. This is, better hold on to your seats. Oh wait, why is it printing things? That was what it was supposed to do eventually, but I wasn't expecting it to do that yet. Why is that happening? That is weird. Well, in the interest of time, I'll just mention what I was going to do next that would make that happen, which was test add. I was going to put this in there, copy this code over the empty top level module from this one, and just put in a tester that calls add and outputs over and over again. This display code, you couldn't actually have this in a program that gets synthesized to silicon. This is only for debugging in the simulator. It calls the adder with a bunch of byte values and then displays the output, and somehow that's what was just getting run. I won't worry too much about why that was. And yeah, so that's the BlueSpec simulator, which will produce a C++ version of your design, so you can run it for quick debugging. And there are the tools for making this run on FPGAs or compiling it towards silicon as well. That's the end for me. Any last questions? Yes?
Why go through OCaml? So that you can create a file, or is there something?
For efficiency reasons, we want to generate the string of source code imperatively. Otherwise, we're just working with functional strings and concatenating them over and over again, you get huge superlinear blowups if your code is large. Yeah?
When you start from the abstract language to the silicon, does the verification break between BlueSpec and the definition?
You mean, is there, in the series of steps in our programming and compilation process, when we go into BlueSpec, have we left the realm of proofs?
Yes.
The answer is yes. And we have ongoing work that's avoiding that by essentially re-implementing a good enough subset of the BlueSpec compiler inside of Calc, so that we leave the world of proofs only when we go to the RTL level, or the starting point that most commercial synthesis tools expect. Yes?
Do you use quick check to first try if this stuff works before
I don't. Yes.
So how far could you eventually, you mentioned you could take this down to lower levels of this RTL thing. Could you also verify something about the layout? Or?
I see no reason why it should be impossible, but I don't know how it would work.